In this video, we are going to learn what Bernoulli's differential equation. So first we need to understand Bernoulli's differential equation, the standard form. What is the procedure if you get this kind of problems? Okay. So let us first understand. We have studied the standard form of linear equation, right? So you might have seen this type of equation where we deal with dy by dx plus py is equal to q. This is nothing but a linear equation in y. We call it as what? Y. Py is there, dy is there. Okay. Now what happens? So p and q are nothing but a function of x will be given over here. We'll be finding out what integrating factor, which is e power integration of p dx. Okay, this is what we used to do. Then apply the solution and get the answer. Now one more equation you might have studied, that is basically the linear equation in terms of what? X. That is nothing but dx by dy plus px equal to q. Now here a slight difference is there. In this linear equation in x, we are having the variable here x and x. So p and q will be function of what? Y. Only y will be there. So it is a function of y. Now integrating factor, we have to take the same thing only, but only change is there, that integrating factor becomes e power integration of p dy. Okay, there is a difference. So these two equations you have studied. So what will, so first one solution is given by what? E power y into e power integration of p dx. That is basically you can write it as y into integrating factor directly. Okay, equal to integration of q into e power integration of p dx plus c. This is the solution for the first one. Now what about the second one? So second one solution becomes the same thing, only in place of y, x will come. So x e power integration of p dy is equal to integration of q e power p dy dy plus c. So this is the change happens over here. This we are dealing with what? Linear equation in x and y variables. Okay. Now what about the differential equation, Bernoulli's differential equation? That is the question. So let us try to understand that. So wherever we are having the differential equation, I will represent with dE of the form dy by dx plus py equal to q power y power n, q into y power n. This is the form where p and q will be what? Function of x. Now you ask me, it is similar to what? The first one. So if you observe the first equation, this part, it is similar to that. Only change is that with q, multiplication of y power n is there. There is only change happening over here. What about this equation? This also we are having the equation same as this one. So we can write that particular equation as dx by dy plus px equal to q into y power n. We cannot write here, it will be x power n, where q and p and q will be what? Functions of y. Now you can observe it's the same thing. Both the equations are slightly the same thing. We can compare it with the linear equation which we have discussed over here. Okay, so these two equations will be same. Only change is that multiplication of this has come. Y power n has come. So how to do the procedure? What is the procedure? So we'll be taking up the first part and we'll be discussing it with this one. And problems also we'll discuss for the first part. Second part of the equation where it deals with the what? X where it deals with Bernoulli's equation in x variable, that we'll be discussing it with. So this is Bernoulli's equation in y variable. Okay, just mention it over here. So it is the Bernoulli's equation in y variable. So this is y variable, but p and q will be function of x. This one is Bernoulli's equation in x variable. Okay, so we'll be dealing with what the Bernoulli's equation in one variable. We'll be solving problems based on that. We'll first discuss the steps. So whenever you're getting the first part of the question, okay, this question, so what is the step we have to follow? The first step is to divide. So what is the first step? First step is to divide the equation by y power n. So why we are dividing it? See, we have to bring it to the linear equation form because this part is extra thing. So we have discussed here. You can see again here this particular equation. If you see y power n is extra thing. So we are going to divide that particular equation, that particular part. So y power n will be divided with the entire equation. Okay, that is the first part. So let us divide. So what happens? It will become 1 by y power n into dy by dx plus py is sitting by y power n is equal to q y power n divided by y power n. So this and this will get cancelled. Y power n you can take it up and this equation becomes what? 1 by y power n dy by dx. Then this is 1 y power 1. If it goes up it will become y power 1 minus n, right? So this will become p into y power 1 minus n. How it is become? Because we are applied the exponential property. What is that? A power m divided by a power n. If base is same, powers are different and quotient is there. The operation between these two is quotient. That means division. So it will become a power m minus n. The same logic we have applied here. Okay, equal to what? Q. This is the equation we have got. So this you mark it as what? First equation. Now let us go for the second step. Second step we have to substitute what? Put y power 1 minus n equal to t. I repeat again what happens here. Whatever is beside p, okay, whatever is beside p, that you have to substitute as what? That you have to equate as what? One variable. Here we are taking t. Some of the textbook might take v also. So here we are taking t. Okay, so beside p, after the first step, remember after the first step, not before the first step. After the first step, whatever is beside the p, you have to substitute, equate it as what? T variable. After this, we are going to differentiate with respect to x. What happens when you differentiate? So this particular thing we are going to differentiate with respect to x. We are differentiating. What happens? So y power 1 minus n, we know how to do. 1 minus n, then y into 1 minus n minus 1 we have to do, it will become minus n. So which property we have applied here? You might have studied this, that x power n, the differentiation is what? N into x power n minus 1. Okay, differentiation. The same property I have applied. But the problem here is that here y is there. So I have to put again differentiation of y with respect to x. Okay, now equal to t is sitting again differentiation of t with respect to x. So this is what after differentiation you will be getting. So we are going to just to simplify the above equation. So it will become, I can write it as 1 by y power n into dy by dx equal to 1 by 1 minus n into dt by dx. Yes, this is possible. I am just bringing this side equal to sign and y power minus n becomes 1 by y power n. So what's the use of doing this? So if we compare the first equation, this particular equation, you observe that this part 1 by y power n dy by dx is same as this part, right? So for that I am just simplifying that particular equation because I want to substitute over there. That's why. Okay, so what happens? Step number 3. Step number 3, we are going to substitute whatever we got over here, okay, this particular thing in equation 1. So we will say that equation 1 becomes Equation 1 becomes what? Just substitute here. This particular part I can just substitute this thing. RHS side, just substitute over there. That is equal to, so 1 by 1 minus n dt by dx. So just observe this particular part I am substituting there, okay? Plus, now p y power 1 minus n will remain as it is, equal to q as it is. Okay, this part is done. Now we'll again simplify some sort of thing. Now again one more thing I'll let you know, that here we are trying to avoid the y variable. Okay, one more thing I should let you know, that we are trying to avoid this, so you can note it over here. So try to avoid, not tried, you have to avoid the y variable in this equation. Avoid y variable. So how to avoid y variable? See here, y 1 minus y power 1 minus n is there. Can I substitute as t? Yes, you can substitute, because you have already said that put y power 1 minus n as t. So I am going to eliminate this y variable and put it as what? Directly t. So in this particular equation there is no y variable. So note that we have to avoid y variable in this. And one more thing, I should again remind you that this is, we are dealing with this equation, Bernoulli's equation in y variable. So we are avoiding here y variable itself. Now we know the standard equation we have studied, that is dy by dx, just we now studied, plus py is equal to q for the linear equation, linear differential equation. This we have studied. So we can we bring it in this form? Don't think about y. Here the variable has become t. So if you observe, the variable has become t because we have avoided the y variable. So you can write it as what? T here. So we have to bring it in this form. Now dt by dx is there already. Okay. Pt is also there. Q is also there. Now dt by dx I want it alone. So I am going to send this that side. So I am going to take what LCM over here. So what happens? The equation becomes dt by dx plus 1 minus n. I am taking the LCM. Okay. So Pt is equal to 1 minus n into Q. Done. This part is done. Now it is exactly in this form. Dt by dx plus Pt is there, equal to Q is also there. Okay. Now step number 4 we'll discuss. What we are going to do? We are going to take the integrating factor, which will be equal to what? E power p dx, integration of p dx. Okay. Then afterwards we are going for the final thing, that is the solution, which can be written as t into e power integration of p dx equal to integration of q into e power p dx plus c. Okay, or in other words you can say is that t into integrating factor, directly you can write, equal to integration of q into integrating factor plus c. This is the solution of this Bernoulli's differential equation in y. Okay, in y. Now we have already studied the, if you compare it with standard, if you compare it with the linear equation, differential equation in y, it will be exactly same. See there, what was the solution? There the solution was y into e power integration of p dx equal to integration of q e power integration of p dx plus c. See, only difference you can see that y variable is sitting over here. Here which variable is sitting? T variable. That is the difference you can see over here. Okay, so when you compare and study, it will be easy for you because you have already studied the linear equation, differential equation. Now we are going to study one more part of that, which is the Bernoulli's differential equation. Now you'll ask me, what about the x? What happens Bernoulli's equation in x? It is exactly the same procedure. Only thing is that we are going to avoid their x variable. The same procedure has to be followed. There we are going to divide it with what? X power n. Then we are going to put what? X power 1 minus n as t. Okay. Then we have to evaluate the same thing. Only thing is that integrating factor becomes there, e power p dy. And here also same thing. P dy will come. And here also p dy will come. Okay. That's the only difference. Okay. So when you study that, it will be easy for you. Okay.